Okay, well, I want to do two quick examples of solving quadratics by completing the square for you. We've already been through a discussion about perfect square trinomials and how you create them, how we use them in completing the square, but a student was asking for a couple of examples he could refer back to on his homework, so you got to give the people what they want. So here we go. First, what we want to do is get the constant to the other side in this equation when we're going to use completing the square. And I encourage my students to do that step in their head. So we have x squared minus 18x equals 319. Now we complete the square here. We're going to take half of negative 18, which is negative 9. And we take that negative 9 and we will square it. What is negative 9 squared? That is 81. So we have completed the square. We do need to remember, though, if we add 81 to the left side of the equation, we need to add it to the right side of the equation. So we add 81 over here also. Where does that take us? And we've created this perfect square trinomial here, which factors into one binomial factor squared. That would be the square root of x squared x, and always this term on the corner here, if you write it up this way, minus 9 squared, and that equals 319 plus 81, 400. Now we have the square term isolated on the left. We are ready to take the square root of both sides and solve our equation. So we take the square root of this side, square root of this side, and x minus 9 equals plus or minus 20. It's fine if you go ahead and solve and get your two answers in your head here. I'm going to write it out just so we can see it clearly. X minus 9 equals positive 20, or x minus 9 could equal negative 20. Add 9, so x equals 29. Add 9 here, and x would equal negative 11. So there's our two solutions we get when we solve by completing the square. So you can see all that at once there. All right, let's take a look at a second example. This one's a little different because it's got an a value here, different than 1. All right, still the first thing we're going to do is move that constant to the other side. So we have 4x squared plus 20x, and that equals positive 11. Okay, so when we have an a value other than 1 here, we're going to factor it out of this expression. So we'll factor the 4 out, and that gives us x squared plus 5x. I end the parentheses here because of this 4 out front, and that equals 11. All right, now we go through the completing the square process. We divide this 5 by 2. I often encourage my students to use fractions, but this time we're going to convert that one to a decimal, and that would be 2.5. All right, and then we take 2.5 and we square it. What is 2.5 squared? That is 6.25. Okay, but we didn't just add 6.25 to this left side. This 6.25 is being multiplied by 4 outside the parentheses here. So we've got to multiply 4 times 6.25, which is actually 25. So it's 25 we added to this side. We need to add 25 to the other side. All right, we've completed the square. Let's go ahead and factor that out there. So we would get x, that's a positive 2.5 squared, and that equals 36. I do need to bring down my 4 here. All right, what is our next step? That would be to divide both sides of the equation by 4. So we have x plus 2.5 squared equals 9. We are ready to take the square root of both sides. So we square root and we square root. And what do we get here? X plus 2.5 equals plus or minus 3. So we need to subtract 2.5 from both of these numbers. So we would get x equals positive 3 minus 2.5, which is 0.5. And our other answer would be negative 3. subtract 2.5, which is negative 5.5. So there are two quick examples of solving quadratics by completing the square. Thank you.